Hey everyone, here is a question that was sent to me from Solomon Island. It's funny how the world became so small. So from Victoria, BC, Canada to Solomon Island, here is the answer, Sandra. All right, so here you're trying to prove this identity. So you want to work on the harder side or the more complicated side, which is the left side here. And to do this, you have to remember your addition identity for the sine and the cos. So in most schools, here at least in Canada, we give the identity sheet to students so they don't have to memorize these. They could just look it up. But when they look at this, they have to remember that they have to use the addition and subtraction identity. So for sine A minus B, that's how it goes. So this will give you sine A cos B minus sine B cos A for that. And you still have all of this all over sine B plus, and the cos subtracting identity is cos A cos B plus sine A sine B all over cos B. And remember, we're trying to prove that this is sine A sine B cos B. So that's what we're trying to prove. This whole thing here equal that. Okay, and cos A minus B, it's a double angle identity, so you could just look it up in your identity sheet. At this stage here, I can't see anything that we could do except start doing common denominator. So when we're doing common denominator, it's a good idea to write a long line and write your common denominator right on the bottom right here. So we know we have to multiply the cos B into this here and the sine B into this. So I'm just gonna write sine, that is cos B, which is that multiplied in all of sine A cos B minus sine B cos A plus this here has to be multiplied in all of this. So sine B multiplied by cos A cos B plus sine A sine B. And we're trying to prove that it equals that. So now just expand cos B in all of this. So we'll have sine A cos squared B, because cos B times cos B is just going to be cos squared B minus, and when we multiply it here, we're just going to get cos B sine B cos A plus, here when I multiply this into here, I'm just going to get the same thing. Sorry, I get sine B cos A cos B. And when I multiply this into here, it's going to give me plus sine squared A, because sine A, sorry, that's going to be sine A and then sine B times sine B is sine squared B. That's what I meant. And all of that all over sine B cos B. Now this is cos B sine B cos A, and this is sine B cos A cos B. Is the same thing, just written in a different order. So we could cancel these. And what we left with here, it'll be sine A cos squared B plus sine A sine squared b all over sine b cos b, which in turn I could factor out the sine a from here as the greatest common factor. I end up with cos squared b plus sine squared b all over sine a, sorry, sine b cos b. So that's b. Now cos squared b plus sine squared b, that's the Pythagorean identity. Cos squared plus sine squared equals 1. So that's all of that just going to be 1. And then you'll have sine a right here on top, and you'd have sine b cos b, which is exactly that. So basically it equals sine a over sine b cos b, and this identity has been proven. And that's how you prove this. So it's a bit lengthy, but if you don't make mistakes with your expansion and stuff like that, you should get to this answer. So this identity has been proved or verified. And that's it. I hope this helps you, Sandra. As always, thanks again for watching. Don't forget to hit that like button, share with family and friends, subscribe to my channel. Till next time, bye-bye.